The ancient Indian temple mystery, precision without technology. When modern engineers analyzed the Brihadeeswarar Temple in Tamil Nadu with laser scanners in 2015, they discovered something that shouldn't be possible. Welcome to one of history's most captivating enigmas. How did ancient Indian craftsmen achieve what modern engineers struggle to replicate, even with computer-aided design and laser cutters? The impossible precision of Ellora. Let me take you to Ellora, where something extraordinary happened between 600 and 1000 CE. Cave 16, the Kailasa Temple, isn't built, it's carved. Imagine this. Artisans started at the top of a cliff and excavated downward, removing 400,000 tons of rock to reveal a temple that was hiding inside the mountain all along. No room for error, no ability to add material back if you carved too deep. The precision is staggering. Modern archaeologists have measured the symmetry of the elephant sculptures that line the base. Each one mirrors the others with less than 2 millimeters of variation. The pillars stand perfectly vertical, carved from living rock, never once having been assembled or adjusted. One archaeologist described it as architectural brain surgery performed with a hammer and chisel. But here's what keeps engineers awake at night: the acoustic engineering. Certain chambers within Ellora amplify sound with such mathematical precision that a whisper at one end carries clearly to the other, 40 feet away. This wasn't accidental. Ancient builders understood wave frequencies and resonance in ways that modern architects are only now beginning to appreciate. The mathematical minds behind the monuments. The secret begins to reveal itself when we examine the Shilpa Shastras, ancient architectural texts that read like sophisticated engineering manuals. These weren't crude guidelines. They were precise mathematical treatises that would make modern architects nod in recognition. The Shilpis, or master craftsmen, operated within a framework of sacred geometry based on the Vastu Purusha Mandala, a mathematical grid system that governed every proportion of temple construction. But calling it merely religious undersells its genius. These grids employed principles of the golden ratio centuries before Leonardo da Vinci made it famous in Europe. They understood load distribution, structural stress points, and how to channel water flow through complex drainage systems that still function perfectly today. Consider the Sun Temple at Konark, designed as a cosmic chariot with 24 wheels, each 12 feet in diameter. Every wheel is a working sundial, accurate to the minute. Think about that engineering challenge, creating 24 separate timepieces, carved in stone, each oriented precisely to track the sun's movement across different hours. They had no protractors, no spirit levels, no laser measuring devices. Yet the astronomical calculations are flawless. The lost art of stone. Whispering here's where it gets truly fascinating. Ancient Indian sculptors spoke of listening to the stone. Before making a single cut, master craftsmen would tap the rock, hearing the grain structure, identifying flaws invisible to the eye, understanding where stress points would develop decades or centuries later. Modern materials scientists have validated this wasn't mysticism, it was sophisticated acoustic analysis. Different rock densities produce different sound frequencies when struck. Experienced artisans could effectively see inside the stone using sound waves, the same principle behind modern ultrasound technology. The sculptures themselves reveal techniques that baffle modern experts. Take the monolithic Gomateshwara statue in Karnataka, carved from a single piece of granite in 983 CE. Standing 57 feet tall, its proportions are so perfect that the statue appears identical whether viewed from 10 feet or 100 feet away, a feat of forced perspective that Renaissance artists wouldn't master for another 500 years. Under magnification, the tool marks tell an intriguing story. The chisels moved in patterns that minimize fracturing, following the crystalline structure of the granite. It's as if the sculptors could see the atomic arrangement of the rock. Modern stone carvers, when attempting to replicate these techniques, find that granite fractures unpredictably. Yet somehow, ancient artisans knew exactly where and how to strike, thousands of times, without a single crack appearing in the wrong place. The assembly mystery: moving mountains. Now for the physics-defying part: the transportation and assembly of massive stones. The Gopuram, entrance tower of the Brihadeeswarar Temple, contains stones weighing up to 80 tons, stacked 216 feet high. Engineers calculate that hoisting such weight to that height would require cranes, hydraulic lifts, and steel cables, none of which existed in 1010 CE. The traditional explanation involves ramps, earth ramps that would have stretched for miles, requiring millions of tons of soil to construct, only to be removed entirely afterward without leaving any archaeological trace. It's plausible, but something doesn't quite add up. The amount of labor and material would have exceeded the temple construction itself. Recent experiments by Dr. V. Ganapati Sthapati, a traditional temple architect, demonstrated alternative methods using the lever principles described in the Yukti Kalpa Taru, a medieval physics text. His team moved 20-ton stones using wooden scaffolding, counterweights, and a technique called jalar, rhythmic rocking that reduces friction to nearly zero. The stones essentially float on wooden rollers lubricated with oils and plant extracts. But the precision of placement remains mysterious. The capstone of Thanjavu's temple sits perfectly centered, with its center of gravity exactly aligned with the structure below. A miscalculation of even a few inches would have created disastrous structural stress. They had one chance to get it right. The chemical mastery behind the shine walk into any ancient Indian temple, and you'll notice something peculiar. The stone surfaces retain a luminous quality, often appearing polished to near-reflective perfection after centuries of weathering. Analysis of these surfaces reveals a sophisticated understanding of chemical engineering. The stones were treated with organic compounds, mixtures of plant extracts, minerals, and natural oils that hardened the surface at the molecular level. The exact compositions remain partially mysterious, as many formulas were closely guarded. Secrets passed through guild lineages. Some idols appear to have been polished using techniques that create microscopic surface patterns, invisible to the naked eye, but visible under electron microscopes. These patterns reduce light scattering, making the stone appear to glow from within. Modern materials scientists call this photonic crystal engineering, and we only developed the technology to create it in the late 20th century. The generational cathedral effect. Perhaps the most overlooked explanation is the simplest: time and dedication operating on a scale modern society can barely comprehend. Many temples took 50 to 100 years to complete, entire human lifetimes dedicated to a single project. Master sculptors began training in childhood, spending decades perfecting their craft before being allowed to work on important statues. A single deity sculpture might represent 10,000 hours of work by a master craftsman at the peak of their abilities. This wasn't an assembly line, it was a meditation in stone. The precision came not from technology, but from the most powerful computer ever created: the human brain, focused with absolute attention for thousands of hours on a single task. The modern blind spot. Our obsession with finding lost advanced technology might blind us to a more profound truth. Ancient Indians achieved precision through superior knowledge, not superior tools. They understood material properties, physics, mathematics, and craftsmanship at a level that industrialization has actually caused us to forget. We've traded depth of knowledge for breadth of technology. A modern engineer can design a temple on a computer in days, but might not notice the slight variation in granite density that would cause a crack in 50 years. An ancient Shilpi spent their entire life learning to read stone. The temples stand as monuments not to mysterious lost technologies or ancient aliens, but to something far more powerful and humbling: human dedication, generational knowledge transfer, and the extraordinary capabilities of the focused human mind. When we measure these structures with our laser scanners and shake our heads in disbelief, we're encountering the limits of our own imagination, not the limits of ancient capabilities. The real question isn't how they did it without modern technology. The question is, what have we lost in gaining it?